Hello everyone, my name is Priyadar Singh and this is task 1 of the Graduate Rotational Internship Program of April 2022 by the Sparks Foundation, where we have to predict the percentage of marks a student obtains on the basis of number of hours he or she studied. The prediction is to be made using the supervised machine learning techniques. Getting started by importing some packages such as NumPy, Pandas, Matplotlib.pyplot and some other useful packages that we will be using further. Now loading the dataset using the pd.readcsv command. After loading of the dataset, we would like to get some insights about the dataset, such as the number of rows and columns it has, some of the entries of the dataset, the various features of the dataset. So using the shape command, we get to know that the current dataset has around 25 rows and 2 columns. Using the head command and passing 10 as parameter to it, we get to see the first 10 entries of the dataset. Using the columns command, we get to see the various features present in the current dataset. And the current dataset has around 2 features, which is hours and scores. Now we would like to check for missing values in the dataset using the info command and isNull.sum command. And the output of these commands on the current dataset concludes that there are no missing values in the dataset. Since there are no missing values in the dataset, we would like to display the dataset graphically. Since there are only 2 features, so putting hours on the x-axis and scores on the y-axis and plotting it on as a scatter plot, we get to see that the number of hours studied and the marks obtained, which are basically the 2 features of the dataset, are linearly associated. Hence, we would be using linear regression to build our model. Proceeding further in building our model, we would like to split the dataset into training part and testing part using the train, test, and split command. We split the data into training part and testing part, and the ratio of the size of the training data and the test data is around 70 to 30. Basically, 70% of the dataset would be used for training part and 30% of the dataset would be used for testing part. And as we can see, since there were 25 rows and 2 columns in the dataset, 17 rows are being used for the training dataset and 8 rows are being used for the testing dataset. Now proceeding further in building our model and fitting it. So using linear regression to build our model and fitting our model using the training dataset. Now we would like to see the accuracy of our model on the training dataset. Using the score command, we see the accuracy of the model, which is around 94.84% using the training dataset, which is pretty good. Displaying this accuracy graphically by using scatter plot. The blue points in the graph are the original datasets point, and the red line is the best fit line made by our model. Moving on to the next part, we would like to test our model on the testing data and check its accuracy. Using score command, we get to see that the accuracy of our model on the testing dataset is around 95.68%, which is also very good. Now we'd like to see this accuracy graphically. Now since the training of our model is completed, we would like to predict how much percentage a student will get if he studies around 9.25 hours per day. And the model which we built predicted that if a student studies around 9.25 hours per day, the marks he would get would be around 92.91%. Now we would like to evaluate the performance of our model by using absolute error, mean absolute error. Basically, lesser the error value, better is the performance of our model. And using the mean absolute error command, we get to see that the mean absolute error of our model is around 4.41, which is pretty low. Hence, we conclude that our model predicted that the student who studies about 9.25 hours per day has a very good chance of getting 92.91% of marks in the examination. Thank you.